Sam boards the cruiser. While waiting for the ship to leave, he notices that a wooden crate falls into the water. The crate, however, comes back up. Why didn't the heavy crate sink? Sam is still wondering about the crate that didn't sink. He observes a similar thing happening to the ice in his soft drink. When Sam pushes the cubes down with the straw, he applies a downward force on the cubes. As soon as this force is released, the cubes move back up. The liquid pushes the cubes upward. This upward push or force is called upthrust. All fluids provide upthrust. Upthrust is also referred to as the buoyant force. How is buoyancy generated? When a body is submerged in a fluid, it displaces an amount of the fluid which is equivalent to its volume. The weight of this displaced fluid pushes the body upward. There is another way of looking at buoyant force. Recall that any liquid exerts an equally distributed pressure within itself and on its container. This pressure increases with an increase in depth. For any immersed object, the pressure from the two sides cancel out. However, because the lower part is deeper, it experiences a stronger push, which is not balanced by the pressure on the top part. This pressure difference produces the buoyant force. Sam is holding a balloon filled with helium gas. Do you think the balloon is also experiencing a buoyant force? The thin book has little weight. The cloth is able to support its weight, and hence it stays on top. The newspaper bundle exerts more weight than the thin book. The cloth is no longer able to support its weight, and hence it bends. However, if you distribute the papers in the bundle and place the same amount of weight spread along the cloth, it hardly bends the cloth. Ice cubes float in water because of the same principle. The water molecules in ice are spread out, occupying more volume. Because of this, ice has lower density than water. Hence, the water pushes the ice cubes upward. Density is the ratio of mass over a unit volume. The same principle follows for the balloon too. The balloon is filled with helium gas. Helium is lighter than air. The atmosphere can be considered as a pool of air. The helium balloon is pushed upward by the air around it. Sam is about to reach the port. As his cruiser approaches the port, a large cargo ship passes by. Amazed at the size of the ship, he wonders how that large mass of iron and steel does not sink into the water. Cargo ships have a very large U-shaped hull, while the baseline is very deep. The large base distributes its enormous weight evenly over the water. The ship is then able to displace enough water and acquire enough buoyant force to float over the water. This is a blimp. Many decades ago, people used these for air transportation. Did you know that the blimp used the buoyant force provided by air to float high up in the sky? The hydrogen gas in the large balloon is lighter than air. The monstrous size of the balloon made it very light and capable of carrying heavy machinery and people. Keeping this in mind, can you work out how a hot air balloon floats? So, we have learned that all fluids exert a buoyant force on objects immersed in them. The weight of the displaced fluid is equal to the weight of the object immersed in it. The density of the fluid and that of the object determine whether the object will sink or float. This fact, along with appropriate modification of shape, is used for building boats, ships, and hot air balloons.